In this video, I will discuss about what is matrix addressing. There are three main topics that I would like to cover in this video, which is the general syntax for matrix addressing with one-dimension matrix as well as two-dimension matrix. And second thing is how do we extract value by using the general syntax. And the third thing that I would like to discuss is how do we insert values by using the general syntax. Okay, let me show you with example in MATLAB. First, let's create a one-dimension matrix, which I will call it A1 equals to a value, a matrix of 3, 4, 5, 6, 7. Okay, and another matrix, which is a two-dimension matrix, consists of 1, 2, 3, 4, 5, 6, and 7, 8, 9. So we have A2 as a two-dimension matrix. Now, let's look at the general syntax for matrix addressing. If it is a one-dimension matrix, matrix addressing syntax simply start with the variable name, which is the matrix that you want to extract certain value, followed by round bracket, and put a single number to refers to the position that you want to extract. Let's say if I want to extract the value from the third position, in this case, I will get the value 5. If I would like to extract multiple values, then I will put multiple numbers that refers to multiple position inside a matrix itself, which means in the round bracket, I will need to put a square bracket also. And let's say I would like to extract the first element as well as the fourth element. Okay, in this case, I will get the value 3, which is the first element of A1, and the value 6, which is the fourth element of A1. So when it comes to matrix addressing for a two-dimension matrix, it will be the same. So let me just show the two-dimension matrix in the command window first. And the general syntax is the variable name of the two-dimension matrix followed by round bracket. Because it's a two-dimension matrix, we need to specify the row number as well as the column number. And remember that these two input, we need to separate them with a comma. So this is the general syntax for extracting values from a two-dimension matrix. So let's try to extract the value 8 from this two-dimension matrix, which is located in the third row and the second column. Therefore, the row number is 3, the column number is 2. So it will give me the value 8. And similar to the matrix addressing with one-dimension matrix, if we want to extract multiple column or multiple rows, we will then need to put them in the matrix, which is using a square bracket. So in this case, let's say if I want to extract from row 1 and row 3, okay, but from second column. Therefore, instead of just a single value, I will put a square bracket, row 1 and row 3. And this refers to second column. So in row 1, I have these 3 value. Second column means number 2. Row 3, I have these 3 values, and the second column means number 8. So this code will extract the value at the intersection, which is 2 and 8. Okay, and you can extract multiple row as well as multiple column. If I would like to extract from first row and third row indicated by this, and I'm going to extract from the first column and the second column. Therefore, I will put multiple row numbers and multiple column numbers. In this case, it will extract the 4 value from me, which is from the first row and the third row, and in the first column as well as in the second column. Okay, now there is a trick that you can use to perform matrix addressing if you would like to refer to all rows or all column. So for example, if I specify that I want to extract all rows, I can just use the colon operator and to indicate all. So if I put it at the left hand side of the comma, that means all rows and column 3, for example. Therefore, it will give me column 3, the values from all the rows. And similarly, we can also use the same approach to extract values from all columns. So let's say I want to extract value from the second row and all column. So I use the colon operator to indicate all columns, and I get the value 456. So let's check and see. In the matrix A2, second row, we have 456, and it's extracting from column 1, 2, and 3. That means all column. So this is the few ways that you could use the general syntax to perform matrix addressing. Okay. Now, when we write a program, usually the matrix addressing code will be placed at the right-hand side of the equal sign. For example, if I want to extract a set of new data equals to A2, second row, and all columns, so I will put the matrix addressing code at the right-hand side of the equal sign that will extract the value and store in this variable. Another things that we can do with matrix addressing is insert value. Okay, so let me create a variable data, which I will initially fill it up with 5 zeros so that it's easier for us to observe the changes later on. So this data now has 5 0. So if I use the matrix addressing code at the left hand side of the equal sign, for example, data bracket the second position equals to -1, let's say. Okay, so when I run this code, it will insert the value -1 into the second position of data. Therefore, we get 0 and -1 in the second position. So similarly, we can also insert value into multiple position by using the same general syntax. Since I want to insert into multiple position, I will then have to use a square bracket. So say now I would like to insert into the first position as well as the fourth position. And the value that I want to insert now is 9. So when I run this code, I will get the value 9 insert into the first position as well as the fourth position. So it will be the same thing for inserting values into a two-dimension matrix.